Hello everyone, welcome back to another video. I'm trying something new again. My last educational video on the Navier-Stokes equation seemed to get some interest, so today I'm back with another similar video to my Navier-Stokes video, but today's topic is going to be slightly shorter, hopefully. It's on concavity in shear and moment diagrams. And like I said in the previous video, I'm specifically choosing these topics that I've previously struggled on myself and topics that don't really have many other videos covering it. So let's just go ahead and get started. So since this video is specifically about concavity, I'm going to go ahead and assume that you already know the basics of shear and moment diagrams. Okay, so when do we actually get concavity in our diagrams? Well, it's when we have a linear profile as a distributed weight, or more commonly, we'll see the linear profile occur in a shear diagram. And since that's more common, that's the case we'll focus on. Okay, great. So now we know when to expect concavity in our diagrams. How do we actually draw them? So, for example, if we take this shear diagram with the linear profile from before, we know we're going to get a quadratic profile in the moment diagram. But how do we draw it? Do we draw it concave down? Or is it concave up? Well, it's actually pretty simple. We know that the moment diagram is just the integral of the shear diagram. And what are integrals? Well, they're just the area under the curve. Okay, so the idea is to take a small slice from the linear profile and then look at the area. Then do the same thing with another part and compare the areas together. If we take a look at the example here, we have a linear profile at the end. So if we compare the areas between a slice here and a slice here, we can clearly see that the first slice has more area. So here's what this tells us. The more area we have, the steeper our slope is going to be on our moment diagram, and vice versa. So, for this example, our moment diagram will look like this, with a concave down concavity at the end. And again, we can see here that our slope is steeper to begin with, and it slowly dies down and flattens out at the end, which matches what our shear diagram tells us, with more area to start with, as it gradually decreases to less and less area. Okay, so here I just wrote out what I said earlier so you can have a physical thing to read. Basically, like I said, the larger the area, the steeper the slope. And the smaller the area, the flatter the slope. Okay, let's go for a few more examples so we can get some practice in. Okay, so let's take a look at this example. It's pretty similar to the first one, but let's go ahead and see what we can do with it. So first, let's go ahead and look at the areas. So we can see that the area is big here, which means we're going to have a steeper slope. And if we look at this slice here, we can see that it's much smaller here, so that correlates to a flatter slope. So our moment diagram should look like this. Okay, here's the next example. I'll give you a few seconds to pause the video if you wish to try it yourself. Alright, let's go ahead and take a look at this one. So, once again, we look at the areas. So for this one, it actually starts out smaller at the beginning, so flatter slope. Then it goes into a larger area, which means it's a steeper slope. So the moment diagram will look like this. Alright, final example. Again, if you want to try it yourself, go ahead and pause right now. Alright, hopefully you paused in time, but let's go ahead and take a look. So this one is a bit different as it passes through the middle, but we still do the same thing. We look at the areas. So let's go ahead and just start from the left and go to the right. So at the beginning of our linear profile, we have a large area, then it goes into a smaller area, then it stays small, and finally it goes back to being a large area. So this means we would expect our moment diagram to be steep, then flat, then stay flat, and then finally go steep again. And we can confirm this is what we see in our moment diagram. We can see it's steep, it flattens out, it stays flat, and then it goes back to being steep at the end. Okay, that's it for this video. I hope I was able to help at least one of you guys out there. But anyways, I'll see you in the next video. I hope you guys have a wonderful day or night or whenever you're watching. Alright, see ya. Bye.